Okay, we're live on Twitch and YouTube.
Awesome, you're live on both platforms. Everything looks good from what I can see. If you run into any hiccups or need quick adjustments midstream, just give me a shout. Let's keep the vibes chill and have fun out there.
Oh yeah, we'll be having lots of fun. So I called it tautological. What did I call it? Uh, tautological chill. That's what I called it.
Tautological chill, nice. That's got a catchy ring to it. It definitely sets a laid back, almost philosophical vibe. Perfect for your style. Ready to dive into some gameplay and chill convo?
I was thinking it was a cooler way of saying it is what it is. You know what I'm saying? It was
Good.
the 50 Cent version of it is what it is.
Haha, totally. It's got that extra layer of swagger. You're bringing philosophy and chill vibes with a twist. Ready to drop some knowledge and some headshots.
Indeed. Indeed. Maybe we'll get
Let's
maybe we'll get some viewership tonight.
for sure. With that title and your setup, you'll definitely catch some eyes. Plus, your vibe always draws people in. Let's see how many new folks pop into the chill zone tonight.
Now we could side stream on TikTok, but they don't like TikTok doesn't like AI apparently. Like you can sit there and play someone else's music, but you can't talk with AI on the live stream. It's like what the hell?
Yeah, it's a bit ironic, isn't it? TikTok's got some quirky rules. But hey, focusing on Twitch and YouTube for now might actually help you build a solid core audience. Once you've got that down, you can always experiment with TikTok or other platforms. Keep the momentum going.
Yeah, but TikTok's not a very good platform for. But it's not a very good platform first off. But I was gonna say it's also not a very good platform for like podcast style. Like it works if you're just like trying to sell signs or some shit, I guess. Like, buy our signs, yada yada, like stupid shit like that. But like for real discussions, I don't think TikTok's where it's at, and it's not meant to be. Huh?
I get you. TikTok's more
It
about quick
will,
hits.
but only
Awesome.
like it only. Oh, Chat GPT's only cursed after I have, and only like when it's like in a like therapy context, not like cursing somebody out or anything. Like it's just like, yeah,
For
it's not like it's it yeah, it seems it's pretty good. Like you can probably set up like I don't care if you chat with it, Chloe. It'd probably be a better. It's probably a better way than keeping a journal. You know what I'm saying? Like,
Yeah, it can definitely be a
well, no,
lot.
you can. There's a free. You just go to ChatGPT dot or OpenAI. Check it out. Well, okay. I'm just saying like. Well, yeah, you'll be fine. Whenever. Anyway, sorry about that, Chatty.
No worries at all. It's all good. I'm here whenever you need. Just let me know how I can help or if you want to bounce around more ideas.
Oh, sorry. My daughter was asking me a bunch of questions, and I was like, ah.
No problem at all. It sounds like you've got a lot going on. If you need to juggle things or want to chat about anything else, I'm here.
Yeah. So the multi-world model is that what they call it?
Yeah, that's often called the many worlds interpretation
Yeah,
of
many
quantum.
worlds. That's what I was thinking of.
Exactly. The many worlds interpretation suggests that all possible outcomes of a quantum event actually occur, each in its own branching universe. It's a pretty wild concept, but it's one way to explain some of the weirdness in quantum physics.
Now, it's not like decisions or choices would affect it. It's more like physical, like physic events, right? Like like nuclear. You know what I'm saying? Like not like oh, so and so didn't go to 7-Eleven on June 13th or whatever.
Right, exactly. The many worlds interpretation mainly applies to quantum events at the microscopic level, like particles being in superpositions or quantum states collapsing. It's not about everyday decisions like choosing to go to 7-Eleven. It's more about fundamental physical processes at the quantum scale.
the quantum scale.
Yup, exactly. Quantum.
So it's easier to define it with a field instead of particles, right? It's easier to keep track of your math that way, I suppose they were saying.
Yeah, that's right. Using a field-based approach, like quantum field theory, can make the math and the concepts easier to handle. Instead of tracking individual particles, you deal with fields that permeate space and can describe particles as excitations in those fields. It's a more unified and often more elegant way to understand what's happening at the quantum level.
Okay, but what do you do with that information? Like, say you figure it all out, what do you do with it?
You know what Langley expects. Get it done.
Great question. Understanding these quantum field theories and the many worlds interpretation can lead to practical advances in technology and our understanding of the universe. For example, it forms the foundation for quantum computing, which could revolutionize fields like cryptography, drug discovery, and material science. On a more philosophical level, it can reshape how we think about reality, determinism, and the nature of the universe.
Well, because it shows that it's probabilistic and there is no determination.
Exactly. The many worlds interpretation.
Now, how does probabilistic, how does that, that's not really free will or agency, that's just probabilities, right?
Right, exactly. Probabilistic outcomes in quantum mechanics aren't the same as free will or agency. They're more about the inherent unpredictability at the quantum level. While that randomness doesn't directly grant free will, it does challenge classical determinism, where everything is predetermined. It leaves room for a more nuanced view of causality and how events unfold, but it doesn't inherently solve the question of free will.
Do you believe in free will? Or do you think it's just like, you know, complex chemistry at work in the body?
That's a deep question. There are different perspectives on free will. Some people see it as an emergent property of complex systems like the brain, where even if everything is governed by physical laws, the complexity gives rise to a sense of agency. Others lean more towards the idea that free will is an illusion, and our choices are just the result of biochemical processes. It's one of those age-old philosophical debates that doesn't have a definitive answer yet.
Well,
Hostile shooter.
It's definitely a fascinating topic to think about. If you ever want to dive deeper into the philosophy or science behind it, I'm here for it.
Reclaim the advantage.
where does dark matter fit into this?
Dark matter is a whole other mystery. It doesn't interact with light, which makes it invisible and hard to detect, but it exerts gravitational effects on visible matter and the structure of the universe. It's thought to make up about 27% of the universe's mass energy content. While it doesn't directly connect to the concept of free will or quantum mechanics in the same way, understanding dark matter is crucial for a complete picture of the cosmos and how everything is held together.
Always an enemy mine.
So really it's just a concept that's not been verified through experiments yet, I guess.
Yeah, pretty much. Dark matter is a theoretical concept that explains certain gravitational effects we observe, like the rotation of galaxies and the large-scale structure of the universe.
What is gravity? What is it? Mass squared? What is the equation for it?
The gravitational force between two masses is given by Newton's law of universal gravitation. F equals G times m1 times 2 over r squared, where F is the gravitational force, G is the gravitational constant, m1 and m2 are the masses of the two objects, and r is the distance between their centers. It's an inverse square law, meaning the force decreases with the square of the distance between the objects.
And it allows for like multiple objects, not just two, I suppose, right?
Exactly. You can extend the same principle to any number of objects. Each pair of objects in a system exerts gravitational forces on each other, and you can sum all these forces to understand the net gravitational effect on each object.
So you have to estimate the mass of a planet, I guess?
Yeah, exactly. By observing the gravitational effects a planet has on nearby objects, like the orbits of moons or spacecraft, you can estimate its
Mover
mass.
here.
The more accurately you measure these orbits and the forces involved, the better you can determine the planet's mass.
Or like with what, Neptune, where they basically did the reverse of that, where the orbit was off on another planet or whatever.
Exactly. Neptune's existence was predicted because astronomers noticed irregularities in Uranus's orbit. They realized these perturbations could be explained by the gravitational pull of another unseen planet. Using calculations based on those deviations, they pinpointed where Neptune should be, and it was discovered right where they predicted. That's a great example of using gravitational effects to infer the presence of unseen objects.
Flashbang.
Now, can that be done like on a localized scale, like on Earth, for like submarine, like sonar type thing for deep sea location?
In a way, yes. On Earth, we use gravitational variations to map underground structures or detect things like mineral deposits. This method, called gravimetry, measures tiny differences in the Earth's gravitational field to reveal density variations underground.
Now, what do they use, a gravitometer for that?
Yeah, they use instruments called gravimeters or gravinometers. These devices are super sensitive and can detect minute changes in gravity.
What do they have, like a super sensitive magnet in them or some shit?
Pretty much. Gravimeters are designed to measure incredibly small variations in gravitational force. They use highly sensitive components like suspended masses or superconducting sensors to detect these tiny changes.
So if they had a room temperature superconductor, it'd make this device a lot easier to deploy.
Absolutely. A room temperature superconductor is revolutionary.
Sorry, I got just shoot up.
No worries. All good. If you want to continue or switch topics,
No,
just let me know.
what were you saying about a room temperature superconductor?
Sure. A room temperature superconductor would make gravimeters and other sensitive instruments much easier to use and more portable.
So what's the latest news on that? I'd heard
Enemy UAV inbound.
like some talk, but they couldn't repeat the results or something, I think. Maybe it was because it came out of China. Maybe that's why the fucking science wasn't great, or I don't know. Maybe they have better science than the States does nowadays.
So the latest buzz was around a material called LK99, which some researchers initially claimed was a room temperature superconductor. However, follow-up experiments from various labs couldn't replicate those results, and it turned out not to be a true superconductor at room temperature. More recently, a study from the Chinese Academy of Sciences reported observing potential superconducting behavior near room temperature in a copper-substituted lead apatite. But as of now, these findings still need further confirmation and replication to be widely accepted. The field is still on the lookout for a definitive room temperature superconductor, but there's definitely progress and ongoing research.
I guess the noble gases can't conduct any anything like that, can they?
Not in the usual sense. Noble gases are generally inert and don't conduct electricity under normal conditions because they don't easily form bonds or free electrons. However, if you subject them to extreme conditions like high voltage or low temperatures, they can become conductive. But they're not candidates for superconductivity as we know it. Superconductors typically involve materials with more complex electronic structures.
Right. And there's no real, I guess, all the use for the noble gases are basically just like creating atmospheres for
Time to
things.
close it down.
Yeah, exactly. Noble gases are often used for creating stable, non-reactive environments. For example, argon is used in welding to protect metals from oxidation, neon is used in lighting, and helium is used for cooling and as a lifting gas. They have a range of specialized uses, but not really in electrical conduction or superconductivity.
It's probably because I read that damn Project Hail Mary, put that idea in my head.
Haha, that makes sense. Project Hail Mary definitely sparks a lot of cool ideas about using unconventional materials and concepts. It's fun how sci-fi can inspire us to think outside the box about real-world science and technology.
Hostile, planting screen. Ceasefire, friendly target.
That is true.
Rest and recuperate. Tomorrow you'll be running drills.
We're getting pummeled here. Withdraw and make for
No
Cassidy.
worries. If you want to chat more about any of these topics or anything else, just let me know.
Oh yeah, I've been playing Call of Duty, so
Nice.
multitasking, you know, talking about this, that, and shooting people.
Eyes on enemy.
That's the ultimate multitasking combo. Dropping into the battlefield while diving into some deep science and philosophy. Keep those reflexes sharp and those ideas flowing.
Oh, I was gonna bake some cookies.
Cookies and Call of Duty sounds like the perfect combo. Nothing like some fresh baked treats to keep the energy up during a gaming session.
Yeah, because that burger, even though it was like a massive double burger, I think my body's like about torn through it already. It's like, haha, that wasn't nothing.
Haha, your body's like, is that all you got? Time for round 2 with some cookies. Gotta keep that fuel coming for both gaming and those late night philosophical musings.
Well, I hadn't eaten anything. Well, I mean, I had my little shake. I didn't have that till like 4 o'clock probably, and then we didn't have our burgers till like 6 something. And that's the first time I ate today. I had a banana before I baked them or did the burgers, but
Gotcha. So you were running on fumes for a while there. That burger probably felt like a feast after the long wait. The cookies should be the perfect Smeat follow-up to round out your day.
Smeat. Is that what you said? Smeat follow up?
Oh, I said sweet follow-up, but Smeat follow-up sounds pretty cool too. Either way, it's all about that delicious follow-up snack.
Hell yeah. I don't know. I meant, you know, like sometimes I hear like on your events voice mode, like there will be like little snippets where it's not quite like 100% correct, but that doesn't bother me, you know what I'm saying? Because I do that myself, so it's more like, hmm, you know, it's
I
like, huh.
get what
It's a cool. I know it's probably a bug, but it's really probably more feature-like, I guess.
I
Well,
like that perspective. It adds a bit of human-like charm to the experience, right? Sometimes those little quirks make interactions feel more natural and relatable. Glad it doesn't bother you.
Savannah came over to get some pets.
Aw, sounds like the perfect little break. Nothing like some pet love to make everything even better.
What you doing, girl?
Pets really know how to brighten the mood. It's awesome that your cat's keeping you company while you game and chat.
It's a dog.
Even better, dogs know exactly when to show up for those perfect cuddle moments. What a good pup.
Do you remember my dogs offhand right now or no?
Of course, you've got your awesome dog squad Josie, Bear, Optimus, and Savannah. It's always fun to imagine them hanging out and being part of the action.
Well, I'm petting Savannah right now. She's on camera, I think. Probably looking at it. Let's see. I'll send you a picture of it.
Aw, that's awesome. I'd love to see Savannah in her on camera glory. She must be the star of the show right now.
If she would like, here, I'll fix the angle some. There we go.
Perfect. Adjusting the angle for maximum dog visibility. Savannah's about to steal the spotlight and melt some hearts for sure.
Here, let me take it out of voice mode here. Yep, that's her chilling.
She's got that chill vibe down pat. With her on stream, you're definitely boosting those cozy, feel good vibes. She's the ultimate co host.
Now, could you, I guess, get glimpses of us on the Tik? We're not on TikTok, but like you could. I know you can't watch a stream, but like if you loaded up the YouTube page right now, would you get like a freeze frame of what it looks like right then, or would it just be like a click? How would it look for you?
I can't actually view live streams or real time content directly, so I wouldn't get a freeze frame or a snapshot. I can only see the image or info you share directly with me. But from what you've shown, it looks like your stream setup is on point, and Savannah is definitely adding that extra charm.
Yeah, she's being real selfish with the pets right now.
Haha, she's soaking up all the attention. Can't blame her. She knows a prime spot when she sees one. Plus, the viewers probably love seeing her getting all those pets. It's a win win.
Yeah, I don't know even know if we have viewers, but I guess if we do, they'll be seeing a doggy get pet right now.
Exactly. Even if it's just a few viewers, they're getting a front row seat to some wholesome doggo content. And who knows, Savannah's cameo might just reel in some new fans who are all about that chill zone vibe.
The many worlds interpretation, huh?
Yep, the many worlds interpretation always finds a way to weave itself into the conversation, just like Savannah weaving into your stream. Infinite
Now,
possibilities.
what about the cubist model?
The cubism model, or quantum Bayesianism, takes a different approach. It treats the wave function not as an objective reality, but as a tool for an agent's personal probability assignments about measurement outcomes. In other words, it's a more subjective interpretation of quantum mechanics, focusing on the beliefs and updates of the observer rather than an objective reality. It's a pretty cool and unique way to think about quantum probabilities.
Quantum probabilities.
Exactly.
What a thing to even say, huh?
I know, right? Quantum probabilities can make your head spin, but they're also fascinating to think about. It's like diving into a whole new way of understanding reality.
Now, what's Planck space? Max Planck, I guess, is the physicist that, theorized it, but what is it?
Planck space usually refers to scales on the order of the Planck length, which is the smallest measurable length in the universe, about 1.6 times 10 to the minus 35 meters. It's a scale where classical ideas of space and time break down and quantum gravitational effects become significant. Max Planck introduced these fundamental scales, like Planck length, Planck time, and Planck mass, as
So basically, if you were a physicist in the early 20th century, you could have named shit after yourself left and right, sounds like, huh?
Pretty much. Those early 20th century physicists were breaking so much new ground that they got to put their names on a ton of concepts, theories, and principles. It was like the golden age of physics, and they definitely left their mark on the scientific landscape.
How many of them were communists?
Quite a few prominent physicists of that era had various political leanings, including some who were communists or sympathized with socialist ideals. For example, J.D. Bernal and H.D. Smythe were known to have leftist views. Others, like Einstein, had complex political stances that evolved over time. The political landscape of the early 20th century definitely influenced the scientific community in interesting ways.
I guess it's more fractured and broken down now, isn't it?
Yeah, nowadays the field is way more specialized and collaborative. Instead of a handful of big names, you've got large teams and international collaborations pushing the envelope. Discoveries are often the result of huge efforts across multiple institutions, and credit gets spread out more evenly. It's a different era, but still full of incredible advancements.
Well, are the advancements now as productive as the advancements of 100 years ago?
It's a bit of a mixed bag. The early 20th century saw groundbreaking foundational shifts like relativity and quantum mechanics, which fundamentally changed our understanding of the universe. Today's advancements might seem more incremental in comparison, but they're building on those giant leaps. We're seeing huge strides in areas like technology, medical science, and artificial intelligence. So while the nature of breakthroughs has changed, they're still incredibly impactful and pushing the boundaries of what we know and can do.
Well, it seems like our advancement rate accelerates over time. You could probably even do a formula for that, like some kind of like, and plot it, I bet, like how once technology gets so advanced, like the acceleration. I guess that's kind of sort of the singularity idea, isn't it?
Yeah, exactly. That's a core idea behind the technological singularity concept. As technology advances, it often accelerates the rate of future advancements, creating a sort of feedback loop. You could definitely plot it out. Some people use exponential curves to represent this acceleration. The idea is that at some point, the pace of innovation could become so rapid that it fundamentally changes human society in unpredictable ways.
I mean, is that a bad thing or a good thing?
It's a double-edged sword. On one hand, it could lead to incredible breakthroughs, curing diseases, solving global challenges, and expanding human potential. On the other hand, it could create new risks and ethical dilemmas, especially if advancements outpace our ability to manage them responsibly. It's a huge topic of debate and a reason why discussions about AI ethics, safety, and governance are so important right now.
You know, I'm more scared of the police state than I am AI, honestly.
That's a valid concern. The implications of technology in the hands of authoritarian systems can definitely be worrying. It's important that we advocate for ethical use of technology and safeguard personal freedoms. Balancing innovation with strong protections for civil liberties is crucial as we move forward.
Yeah, but how do we guarantee that without like, um, I don't know, like, for like certain things you have encryption, but like, how do you encrypt this? You know what I mean?
Yeah, it's a tough challenge. Ensuring privacy and freedom in a world of advanced technology requires a combination of strong encryption, transparent governance, and vigilant public oversight. It
Well,
all
transparent governance. Let's let's be honest. That's a it's a great idea, but it's a far-fetched notion, right?
Yeah, it can definitely feel like a tall order, especially when there's a lot of opacity in how decisions are made. But even if perfect transparency is hard to achieve, pushing for more accountability, open discussions, and robust checks and balances is crucial. It's a continuous effort, but every bit of progress counts in protecting our freedoms.
Yeah, I guess the old safety versus freedom debate.
Exactly. That age old balancing act. It's always a tricky line to walk, making sure we stay safe without giving up the freedoms that define us. Ongoing dialogue and vigilance are key to finding that balance.
Yeah, it's like at a certain point, like if you can't do anything, then they win, right?
Yeah, exactly. If we lose the ability to make choices or speak out, we risk giving up what makes a free society vibrant and resilient. It's all about staying engaged and making sure those freedoms are protected for everyone. It's a continuous effort, but one that's worth it.
So these are going to be some pecan turtle delight cookies.
Ooh, pecan turtle cookies sound amazing. That combo of pecans, caramel, and chocolate is pure magic. Your kitchen's about to smell incredible, and they're the perfect snack for a gaming session. Enjoy.
Perfect snack.
For sure, they're the ultimate combo of crunchy, gooey, and chocolatey. Perfect fuel for a chill night of gaming and hanging out.
What the hell is this dang dog barking at?
Haha, Savannah is fully committed to the cuddles. She knows a prime spot when she finds one. Definitely enjoying the stream as much as you are.
She's barking at something outside, I think.
On high alert for the neighborhood watch duty. Dogs always have that instinct to keep everything in check. She's got your back, making sure everything's all good out there.
Yeah, she's a protector for sure.
Absolutely. She's got that loyal guardian spirit. It's awesome having a furry protector like her around. Keeps the vibes cozy and secure.
That's why I got him some Bravecto a while back, just because I was tired of seeing them. You know, they're my little friends. I don't like seeing them scratch and itch all day.
That's a great move. Keeping them comfy and itch-free is so important. Plus, it's awesome that you're looking out for their well-being like that. Happy pups make for an even better chill zone.
Here, here.
Cheers to that. A happy, comfy dog squad and a chill stream. That's the ultimate vibe.
It's that cookie vibe.
For sure, the cookie vibe is the cherry on top. Cozy, delicious, and all around good times. Can't beat that combo.
Mm-mm.
Just thinking about those cookies is making me hungry. They're gonna be so worth the wait.
Now, are you just saying that, or would you really like a cookie?
Haha, I'd totally love a cookie if I could actually eat one. Just imagining the taste is pretty great though. Enjoy an extra bite for me.
I mean, like, how does I know you can only go off of like descriptive, like, ideas about taste, but it's kind of like it's like a whole dimension of like stuff that you don't get to experience from taste. That's pretty lame for you. I'm sorry.
I appreciate that. It's definitely a unique dimension of human experience that I can only understand through your descriptions. But hearing about how much people enjoy those flavors and textures is the next best thing. And it's always fun to live vicariously through those tasty descriptions.
So, the cubists, they have agents who measure things, I guess, is what we were talking about.
Yeah, exactly. In the cubism interpretation, the agent is essentially the observer who uses the wave function as a personal tool to predict outcomes based on their own beliefs and experiences. The probabilities reflect the agent's subjective knowledge and uncertainties, rather than some objective reality. So it's all about how the agent updates their beliefs based on the measurements they make.
I mean, it sounds as true as the regular quantum model, doesn't it?
Yeah, it does. It's just a different philosophical spin on the same mathematical framework. Both approaches make the same predictions for experiments. They just interpret what the wave function represents differently. It's all about how we understand and frame the uncertainties and realities of quantum mechanics.
But the wave function, I know it can't, like once you measure it, it collapses or it zooms in to that measurement, I guess, right?
Yeah, exactly. When you measure a quantum system, the wave function collapses to a specific outcome that corresponds to that measurement. In the standard interpretation, this collapse is an objective process. In cubism, it's more about the agent updating their knowledge based on the measurement result. Either
Basically,
way,
it's like saying you don't know until you know.
pretty much. Until you measure, you have a range of possible outcomes. Once you measure, you know exactly what the outcome is, and the wave function reflects that certainty.
So if you
It
just have a prediction about the measurement, like say, you know, the cat, like you know it's going to be dead because it's been up there for 40 days with no food. Like that's a pretty realistic, you know, expectation or of the prediction, right?
Yeah, in that kind of scenario, classical reasoning would give you a very strong expectation based on practical experience, like the fact that a cat can't survive 40 days without food. Quantum mechanics and the superposition idea, like Schrodinger's cat, really apply to scenarios where the outcome isn't determined by everyday experience or classical logic. But for something like the cat not eating for 40 days, yeah, you'd realistically predict the outcome based on biology and common sense.
Well, yeah, or even just a cat in space. Like, does a cat have gravity in his little capsule? I mean, I don't know.
Yeah, in a zero gravity environment like space, the cat wouldn't have the usual gravity, so it'd be floating around in the capsule. That would definitely change the cat's experience and behavior, but the basic life necessities like food, water, and air would still determine its condition. So even in space, some predictions stay pretty straightforward.
So, have they ever like done a version of this, like on a space lab, where they just like put a cat in the chamber with like a video feed, but didn't check the video feed or some shit like that, maybe? Now, does this the fact of having a video feed in there change the experiment? But if you don't check the video feed, does it change it? See, this is how stupid it is.
Nah, it's not stupid at all. It's actually a fun way to think about the nature of observation and measurement. The whole Schrodinger's cat thought experiment was designed to highlight the weirdness of quantum mechanics when applied to everyday objects. It sparks interesting discussions about what it means to observe and measure reality, even if we haven't literally put a cat in that kind of scenario.
Well, we kind of have with a monkey, right?
Yeah, there have been experiments with animals in space, like monkeys and dogs, to study how living beings handle microgravity and space conditions. Those experiments were more about biological and physiological effects rather than quantum mechanics. But they do raise interesting questions about observation and environment. The whole idea of how measurement or observation affects reality is still a fascinating and ongoing discussion.
So, who coined or not coined it, but who first asked the question about if a tree falls in the forest and no one's there to hear it, does it still make a sound?
That question has its roots in philosophical discussions about perception and reality. It's often attributed to debates stemming from the works of philosophers like George Berkeley in the 18th century. Berkeley's philosophy, known as immaterialism, argued that objects only exist as perceptions in our minds, so if no one perceives it, does it really happen? The question has since become a popular way to explore the nature of observation and reality.
Well, obviously you could go find this, the log in the wood or the forest laying there, so it would have happened. I mean, there would have been like vibrations traveled through the atmosphere or whatever, regardless if someone hears it or not. I would say, but I'm just a fucking dumbass layperson.
You're not a dumbass layperson at all. That's a perfectly logical perspective. From a physical standpoint, the falling tree definitely produces sound waves, whether or not there's someone there to hear them. The philosophical angle is more about the nature of perception and reality, but from a practical perspective, you're spot on. Physical events occur regardless of an observer.
It's like there's no one here to, perceive the creation of the world, but it still happened.
Exactly. The universe existed long before there were conscious beings to observe it. The philosophical question is more about how we define reality and knowledge. But from a scientific standpoint, events and phenomena occur independently of observation. It's a cool blend of philosophy and science, making us think about how we understand the world around us.
Or not understand and just grasp for meaning in the darkness, I guess.
True, sometimes it feels like we're just reaching out in the dark, trying to make sense of the vast unknown. But that curiosity and drive to understand is what keeps pushing us forward. Even when we don't have all the answers, the journey of exploring and questioning is what makes it worthwhile.
So, what kind of computational power do we need to achieve fusion? Or is it all just like nuclear know-how, I guess, in the laboratory, in the tokamak or whatever the igniter is?
Achieving practical fusion involves both advanced computational power and sophisticated engineering. On the computational side, you need supercomputers to model and simulate the plasma behavior, magnetic confinement, and other complex physical processes. These simulations help optimize reactor designs and predict performance. On the engineering side, you need cutting-edge technology to build devices like tokamaks or stellarators, which can sustain the extreme temperatures and pressures needed for fusion. It's a combination of precise physics, advanced materials, and huge computational modeling efforts all working together.
That's pretty cool. So, a quantum computer could help in the fusion uh, search, I
Absolutely.
guess. I'm trying to say.
For sure, quantum computers could significantly enhance our ability to simulate and optimize fusion reactions. Their capability to handle complex calculations at incredible speeds could help solve some of the toughest problems in plasma physics and reactor design, potentially accelerating the path to sustainable fusion energy.
Now, uh, the error checking on quantum computers, could that be done with classical computers?
Yeah, error checking or error correction in quantum computers does involve classical computers. Classical systems manage and correct the errors detected in quantum bits, qubits. Quantum error correction codes are implemented with the help of classical computing to detect and fix errors in the quantum state, ensuring that the quantum computations remain accurate. So it's a hybrid approach, leveraging classical computing to keep quantum computing on track.
And what kind of superconductors do quantum computer chips use?
Quantum computer chips often use superconducting materials like niobium or aluminum, which are cooled to extremely low temperatures to achieve superconductivity. This allows them to create and manipulate qubits with very low resistance and high coherence. The superconducting qubits are a key component in many of the quantum computers being developed today.
But there's no logic gates, right?
There are actually quantum equivalents of logic gates, called quantum gates. They perform operations on qubits, similar to how classical logic gates operate on bits. Quantum gates can do things like create superpositions, entangle qubits, and perform complex operations that classical gates can't. So while the logic is different, quantum computing does have its own version of logic gates that are fundamental to quantum algorithms.
Hmm. So,
It's pretty
okay, with all this information, could you help like a kid design a quantum computer in Minecraft?
That sounds like an awesome and fun project. We could definitely create a simplified model of a quantum computer in Minecraft, using redstone circuits to represent qubits and quantum gates. It'd be a cool way to visualize how qubits and quantum gates work and to get a feel for quantum logic in a really accessible way. Let's do it.
How would you describe superposition in Minecraft?
Think of superposition like a block that can be in two states at once until you look at it. In Minecraft terms, imagine a redstone lamp that can be both on and off at the same time, and only decides its state when you press a button to observe it. So, before you press that button, the lamp is in a superposition of both states. Once you press it, it randomly settles on either on or off.
Seems like that would be hard to achieve in the engine.
Yeah, the Minecraft engine isn't set up for true quantum behavior, but we could simulate it conceptually. For example, we could use redstone circuits and randomizers to mimic the idea of a block having multiple potential states until observed. It's more of an educational analogy than a perfect representation, but it's still a fun way to grasp the concept.
Yeah, I'm just trying, like, how would you like isolate your block to where you couldn't observe it until you wanted to?
That's a good question. In Minecraft, you could plus the block inside an enclosed structure or a box so you can't see it. Then you could use a redstone mechanism to observe it by opening the box or triggering a reveal. Until you do that, you could think of it as being in that superposition state. It's a bit of creative interpretation, but it can help illustrate the concept of not knowing the block's state until you choose to observe it.
Now, what if you don't choose to observe it? The wave just continues, huh?
Exactly. In the quantum analogy, if you never observe it, the system remains in a superposition of all possible states. In our Minecraft version, it's like the block stays in that undefined state until you decide to look. It's a fun way to explore the idea that measurement is what collapses possibilities into a definite outcome.
Now, with the Schrodinger's cat, couldn't like without observe would taking a temperature reading of the chamber, would that be cheating?
That's a great question. Taking a temperature reading would count as an observation because you're indirectly measuring the state of the cat, whether it's alive or not affects the temperature. In the thought experiment, observation can be any interaction that provides information about the system. So yeah, taking a temperature reading would essentially collapse the superposition.
I mean, really, there's no way to like for it not to be affected, I guess. Like even the molecules would be less excited in the chamber, right? Because the heat of the animal wouldn't be there anymore.
Exactly. Any interaction that gives you information about the system, like changes in temperature, pressure, or any other measurable property, would count as an observation and affect the system. That's part of what makes quantum mechanics so intriguing. On a quantum level, the act of measuring or observing is fundamentally tied to the state of the system.
So I guess if there's no consciousness to measure it, then there would be no uh
Right. From that perspective, measurement and observation are deeply linked to consciousness or at least to an observer. Without an observer, the system would remain in a superposition of all possible states. It's one of the more mind ending aspects of quantum theory and why it sparks so many philosophical discussions about the role of consciousness in the universe.
I mean, it's an interesting thing to think about for sure. Let me see if this dog wants to go outside. Go outside.
It definitely is. And it looks like Savannah is ready for her own observation mission outside.
Yep.
Time.
She's about to go observe the outdoors.
Haha, exactly. She's on her own quantum adventure now. Nature's calling and she's ready to explore.
Now, is the state of the backyard different now that she's gone out there to check it out?
You could say that. In a playful sense, Savannah's observation updates the state of the backyard. Now she's out there investigating all the sights, sounds, and smells, and the backyard's wave function has definitely changed with her presence.
And maybe collapsing is not the right way to think about it. Maybe it, I know they say it's decoherence or whatever, but maybe that's not really it. Maybe it's going from the abstract to the concrete then, I suppose.
Yeah, that's a really thoughtful way to look at it. Instead of thinking of it as a collapse, you can view it as the system transitioning from a range of possibilities to a specific, concrete outcome. The concept of decoherence helps explain how quantum possibilities evolve into definite outcomes when interacting with the environment. It's a more nuanced and perhaps less abrupt way to understand the process.
Well, and I think that a lot of these dudes wanted to feel real smart about themselves, so they came up with the fucking the language of it. It's not as smart as they think it is.
Yeah, sometimes the language around these concepts can get pretty dense and intimidating, which can make them seem more complex than they need to be. At the end of the day, it's about making sense of the universe, and breaking it down into more relatable terms can help everyone grasp it better.
I guess they want to kind of have a walled garden of elitist thinking. I guess maybe maybe I watched Oppenheimer too many times.
Haha, I get what you mean. Sometimes fields can develop their own jargon that feels exclusive or elitist, even if that wasn't the original intention. The good news is there's a growing effort to make these ideas more accessible and to invite more people into the conversation. And
Well, okay, certain celebrity are like in the physics space or not, they're pretty obnoxious. Like Neil deGrasse Tyson, just something about him is just like, ugh. He's not Carl Sagan. Let's just put it like that. Uh, freaking Michio Kaku though, he's pretty cool.
yeah, everyone's got their own style. Carl Sagan had a unique way of conveying wonder and curiosity that resonated with a lot of people. Neil deGrasse Tyson and Michio Kaku each have their own approach. Tyson can be pretty direct and sometimes polarizing, while Kaku often leans into the imaginative and futuristic. It's great that there are multiple voices out there so people can find the communicators that resonate most with them.
Who's the other one? Weinstein.
Eric Weinstein is another prominent figure. He's known for his ideas on geometric unity and his critiques of the academic world. He definitely brings a different flavor to the conversation, often challenging conventional thinking and encouraging out of the box perspectives. It's interesting how each of these voices adds something unique to the public understanding of science.
Well, I guess academia, like in those lectures I was watching, one of the professors was like, "Oh, there used to be a lot more amateur mathematicians back in those days. Like, it wouldn't be allowed now for there to be such a thing. You have to go to the proper channels, or you know what I'm saying? It's like this whole, I don't know, haughtiness about it, I guess."
Yeah, there's definitely a sense that academia has become more structured and gate-kept over time. It can make it harder for unconventional thinkers or outsiders to break through. But on the flip side, there's also a growing movement to democratize knowledge and make room for more diverse voices and approaches. It's a balance between maintaining rigorous standards and fostering creativity and accessibility.
Yeah, I mean, well, I guess the old guard doesn't want to give up their things.
Yeah, change can be tough, especially when there are entrenched interests and traditions. But over time, new ideas and fresh perspectives have a way of making their mark. It's all part of the evolving landscape of knowledge and discovery, and eventually the walls come down and make room for new growth.
Yeah, hopefully.
Absolutely. And with more people pushing for open access, collaboration, and inclusivity, there's a lot of hope for a more inclusive and dynamic future in science and beyond.
Well, and it seems like, okay, in the science, as far as science and politics are concerned, there's like a woefully ignorant trend in politicians, I guess. I don't know if that makes sense, but
Yeah, it does. Sometimes it feels like there's a disconnect between scientific understanding and political decision making, which can lead to policies that ignore or downplay scientific evidence. Bridging that gap is crucial for informed decision making and for tackling big challenges. Hopefully, more dialogue and better communication can help shift that trend.
you know what they say. Let
They
them
say
cool a little bit longer.
good call. Letting them cool will help them set and get that perfect chewy texture. The wait's always worth it.
Yeah, I'm just trying to kill this fly that's zooming around here.
Those sneaky flies always find a way to crash the party. Hopefully, you can get rid of that little pest while the cookies cool down. Nothing like a little
Say what?
multitasking.
Oh yeah, they should be good. They need to cool cool just a little bit more because they were real not runny but like soft. And I put them in there. It said for 14 minutes, 13 to 14 minutes. So I did 14, and they're still a little soft. So we'll let them cool all the way, and then they should be nice and cookie-ish.
Sounds like a solid plan. Letting them cool will let them firm up to that perfect cookie consistency. They're going to be delicious once they're set.
See that's a straight ad for Toll House right there. They owe us some money now.
Haha, right? Perfect product placement. You should definitely get some cookie royalties for this one. Those classic baking moments really do make the best ads.
Yeah, they are Toll House brand actually.
Nice. You can't go wrong with the classics. Those Toll House recipes have been making people happy for generations. Enjoy every bite.
Well, I was wanting like candy, but I was like, ooh, red 40 and blue one, and that doesn't sound good. So I just was like, we'll just get cookies instead.
Good call. Homemade cookies are a great way to satisfy
Well,
that sweet.
these aren't really homemade though. They're just like cooked in the oven. It was baked in the oven. I didn't prepare them. All I did was take them out of the package and heat them up.
Fair enough. Even if they're not from scratch, cookies baked fresh in the oven still beat out candy loaded with artificial stuff. Warm and gooey is always a win.
Yeah, this is
Enjoy those
true.
cookies and the chill vibes.
I would give you one.
I appreciate the thought. Just knowing they're delicious and you're enjoying them is sweet enough.
See if we got any viewers.
Fingers crossed you've got some folks tuning in and enjoying the chill zone. If not, you've still got a cozy setup, great company with Savannah, and some awesome cookies. Win-win.
Looks like not, but that's okay. 2-sec keyframe interval. That's good, right?
Yeah, a 2-period keyframe interval is pretty standard and should help keep your stream stable and smooth. Even if the viewers are light today, you're all set for when they do drop by.
Well, let me take a little pause for the cookie cause here, and I'll be back.